graphical solutions of equations. This is a funny bit in maths. It's normally something that pupils find quite difficult. But essentially what it is we've got a graph that has been drawn for us. So a quadratic graph has been drawn and we're using that graph to solve some other equation. So it is very similar to solving equations simultaneously with graphs. It's just slightly different because what we need to do is manipulate what our graph is. So once one has been drawn, and it's possible to solve lots of different equations by rearranging them so that the left-hand side of the manipulated form is the same as the equation that the graph is drawn. So what we need to try and do is manipulate the equation we're trying to solve, and by a means of adding, subtracting, multiplying or dividing, get it to the form of the graph. So the key to this is we're trying to manipulate it to get from the equation and get it to the graph. So in this example, we've got the graph has been plotted for us of x squared minus 3x minus 2. We're trying to use it to solve x squared minus 3x equals 0. So what we need to try and do is manipulate the equation to the graph. So the left-hand side of the equation, we want to have x squared minus 3x minus 2. So we need to ask, well, how do we get from x squared minus 3x to x squared minus 3x minus 2? And that's by taking away 2. Now if we do that on the left-hand side of the equation, we need to do it on the right-hand side. So if we do 0, take away 2, we get minus 2. So that means then we have to draw the graph of y equals minus 2. And where the lines y equals x squared minus 3x minus 2 and the line y equals minus 2 meet, that will be our solution. Now y equals minus 2 is a horizontal line that passes the y-axis at minus 2 and will look like this. And then we can see that there are 2 points where they meet. And the first one has an x value of 3 and the other one has an x value of 0. So x equals 0 and 3. So the second example then is x squared minus 3x equals 5. What we need to do is get from the equation to the graph. So the equation of the graph was x squared minus 3x minus 2. So we need to get from the equation to that, and what we need to do is subtract 2. If we do it to the left-hand side, we have to do it to the right, and then 5 take away 2 is 3. So the equation of the curve is x squared minus 3x minus 2. We need to then draw the line of y equals 3. Y equals 3 is a horizontal line, crossing 3 in the y-axis. And again, we can see that it meets at 2 different points. So working down what the x values are. So we can see the first one there is 4.2, and the second one is minus 1.2. So that gives us solutions of x equals 4.2 and minus 1.2. Example C, x squared minus 4x plus 1 equals 0. So again, what we need to do is get from the equation to the graph. So the equation is x squared minus 3x minus 2. To get from minus 4x to minus 3x, we need to add an x. To get from 1 to minus 2, we need to take away 3. So if we do that on the left-hand side, we have to do that on the right. And 0 plus x, take away 3, is x take away 3. So we need to draw the graph of y equals x minus 3. To do so, a table of values is good. So x, y, pick 3 x values, say 0, 1, and 2. When x is 0, y is negative 3. When x is 1, 1 take away 3 is negative 2. When x is 2, 2 take away 3 is negative 1. So our coordinates there are 0 minus 3, 1 minus 2, and 2 minus 1. We can join those lines up and form a straight line. And now we look for the x values of where the line and the curve meet. So the first one is here, and the second one is just there. So you're looking then at x values of 0.3 and 3.7 approximately. Example 12, the graph of y equals 2x squared minus x minus 3 has been drawn. Solve 2x squared minus x equals 7. So again, what we need to do is get from the equation to the graph. So 2x squared minus x equals 7 to 2x squared minus x minus 3. To do so, the x squareds are good, the x is good, so we need to take away 3. If we do that on the left, we need to do that on the right, and we get that that equals 4. So we need to draw the line of y equals 4. Y equals 4 is a horizontal line passing through at 4. We then look to see where the lines cross the x-axis, and the first one is here and the next one is there. So the x values are going to be minus 1.6 and 2.1, or there and thereabouts. Example 13, here's the curve of y equals x squared. Use it to solve each of these equations. So x squared equals 7. So we need to try and manipulate it so that we get the equation to the graph. So the equation is x squared equals 7. The graph is x squared. We actually don't need to do anything to it. So the x squareds match up. So then we just need to draw the line y equals 7, which is a horizontal line passing through the y-axis at 7. So it's this line here. And where the line and the curve meet, we look at the x values, and the x values are going to be x equals minus 2.65 and 2.65. Example B, we've got x squared equals x plus 5. We have to get the equation to the graph. So the graph is x squared. They actually match up, so all we need to do is draw the graph of x plus 5. So y equals x plus 5, we need to do our table of values. 3x values 0, 1 and 2. 0 plus 5 is 5, 1 plus 5 is 6, 2 plus 5 is 7. Our 3 points then are going to be 0, 5, 1, 6 and 2, 7. And we can join those up with a straight line. And again, we see that the lines meet at 2 different points. The first of which is minus 1.8, and the second, which is at 2.8. Part C, we've got x squared plus 2x equals 1. Again, we're trying to get the equation to the graph. To get from x squared plus 2x to x squared, we need to add a 2x. If we do that on the right hand side as well, we'll get 2x plus 1. So we need to draw the line y equals 2x plus 1. To do so, we use the table of values. So when x equals 0, 1 and 2. So when x equals 0, 2 times 0 is 0 plus 1 is 1. When x is 1, 2 1s are 2 plus 1 is 3. And when x is 2, 2 2s are 4 and 1's 5. So we get the coordinates 0, 1, 1, 3 and 2, 5. And again, we can draw a line And where the line and the curve meet, we've got the x values of minus 0.4 and 2.4. Example 14, given the graph of y equals x squared minus 4x minus 3, what straight line would you need to draw? So we don't have to actually draw them here, we just need to figure out what we need to do. So in example A, we've got x minus 4 equals some fraction. If we multiply through by x, we get x upon x minus 4 equals 3. Expand the brackets, we get x squared minus 4x equals 3. And bring the 3 over, we get x squared minus 4x minus 3 equals 0. What we need to do is get from the equation to the graph. The graph that has been drawn is x squared minus 4x minus 3. To get from the equation to the graph, we don't need to do anything. So if we don't need to do it on the left-hand side, we don't need to do it on the right-hand side. So it's going to equal 0. So then we draw y equals 0, which is the x-axis. Example B, if we bring everything to one side, we get 2x squared minus 8x plus 3 is equal to 0. And what you might think getting from the equation to the graph, which is x squared minus 4x minus 3, you could take away an x squared, you could add a 4x, and you could take away 6. And whilst that is true, and you could draw the line y equals, the curve, y equals x minus x squared plus 4x minus 6, sadly it is not a straight line, so this technique is not right. So what we need to do then, or what we should be doing instead, is first of all get from 2x squared to 1x squared a different way. And that's if we divide through by 2. So if we do that, we get x squared minus 4x plus 1.5 equals 0. And now to get from there, which is the equation, which is the same as the equation above, to the graph of x squared minus 4x minus 3, we need to subtract 4.5. But if we do that on the left, we have to do that on the right. And that will give us minus 4.5. So we draw the line, y equals minus 4.5. Example C is similar to example A. We've got a term equal to a fraction. We multiply through by the denominator, and we get x brackets x minus 3 equals 8. Expand the brackets, x squared minus 3x equals 8. Collect to one side, x squared minus 3x minus 8 equals 0. We need to get from the equation to the graph. So the graph is x squared minus 4x minus 3. To get from minus 3x to minus 4x, we need to take away an x. From minus 5 to 3, add on 5. If we do that to the left, we have to do it to the right as well. And we get minus x plus 5. So we draw y equals minus x plus 5, or y equals 5 minus x. Example 15, plot the graph of y equals x squared minus 3x minus 3 for minus 4 to 6. So what we need to do for this is draw a table of values. So our table of values will range from minus 4 to 6 because y is made up of x squared minus 3x minus 3. We put these columns in. So we need to work out all the x squared values. So when x is minus 4, x squared is positive 16. When it's minus 3, it's 9. When x is minus 2, x squared is 4. When it's minus 1, x squared is 1. Then 0. 1 squared is 1. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and 6 squared is 36. Minus 3x is minus 3 multiplied by x, so minus 3 times minus 4 is 12, minus 3 times minus 3 is 9, minus 3 times minus 2 is 6, minus 3 times minus 1 is 3, minus 3 zeros are 0, minus 3 times 1 is minus 3, then minus 6, minus 9, minus 12, minus 15, and minus 18. And the last one is minus 3, and that's going to be minus 3 right across the board. Because it's not dependent on x, it's just a minus 3. So regardless the value of x, the value is always minus 3. Then if we add the three values of 16, 12 and minus 3, we get 25, then 15, then 7, then 1, then minus 3, minus 5, minus 5, minus 3, 1, 7, and 15. So we can plot those values out. So minus 4 corresponds with 25, minus 3 with 15, minus 2 with 7, minus 1 with 1, 0 with minus 3, 1 with minus 5, 2 with minus 5, 3 with minus 3, 4 with 1, 5 with 7, and 6 with 15. And if we join that up with a nice smooth curve, we get this shape. Now it's important to see that at the bottom we didn't just draw a straight line between minus 1 and 2. We did a curved line. So this is a curve, so it needs to be smooth the whole way along. There shouldn't be any straight edges, so we have to dip below the minus 5 here, and we get this shape. So now we can solve the questions. So part 1 is x squared minus 3x minus 3 equals 0. We need to get from the equation to the graph. So the graph is x squared minus 3x minus 3. So we don't need to do anything to it. So then we don't need to do anything to the right hand side. So we draw y equals 0, which is the x-axis. So we don't really need to draw anything. We just need to see where they cross. And we can see they cross at minus 0.9 and 3.9. So those are our two x values there. Part 2 is x squared minus 3x minus 3 equals 4. We need to get from the equation to the graph, and the graph equation is x squared minus 3x minus 3. To get from the equation to the graph, we don't need to do anything, so we don't need to do anything to the 4. All we need to do is draw y equals 4. We have x values then that correspond to 4.5 and minus 1.6. Part 3, the equation is x squared minus 3x plus 1 equals 0. We need to get it to the form of x squared minus 3x minus 3. The x squared and the minus 3x are good. We just need to get from 1 to minus 3, which is take away 4. So if we do that on the right, we get minus 4. So we need to draw y equals minus 4. And we get corresponding x values of 2.6 and 0.5. Part 4, we've got 2x squared minus 6x minus 11 equals 0. Now what we need to think about is to get from the 2x squared to the x squared, we have to first of all divide by 2. And we get x squared minus 3x minus 5.5 equals 0. Then to get from the equation to the graph, which is x squared minus 3x minus 3, we need to take away 2.5, which means we need to do it on the right hand side. We get minus 2.5. So we need to draw y equals minus 2.5, which is a horizontal line passing through at minus 2.5. We get corresponding x values of minus 0.5 and 3.1. Part 5 is 9 plus 3x minus x squared equals 0. So if we take everything to the other side, or alternatively divide through by a minus, we get x squared minus 3x minus 9 equals 0. We need to get from the equation to the graph. So the graph was x squared minus 3x minus 3 equals 0. The x squareds and the minus 3x match up. We just need to get from minus 9 to minus 3. And to do that we add 6. So we have to add 6 to the right, and we get 6. So then what we need to do is draw the line y equals 6. So y equals 6 then is a horizontal line that passes the y-axis at 6. And we can find the corresponding x values to be 4.8 and minus 2.9. And lastly, part 6, we've got x squared minus 5x minus 6 equals 0. We need to get to x squared minus 3x minus 3. To get from minus 5x to minus 3x, we need to add 2x. From minus 6 to minus 3, we have to add 3. We need to do the same on the right, and we get 2x plus 3. So what we need to do is draw the line y equals 2x plus 3. To do that, we use the table of values. So when x equals 0, x equals 2, and x equals 4, say. So x equals 0, 2 zeros are 0, plus 3 is 3. 2 2s are 4, plus 3 is 7. 2 4s are 8. 8 plus 3 is 11. So our coordinates there are 0, 3, 2, 7, and 4, 11. And if we join those up using a ruler, we get x values of 5.9 and minus 1.